Hello, welcome to another class. We are going to look at probability, and this is a Form 3 topic, and usually tested on Mathematics Paper 2 in KCSE. So, on this lesson, we are going to look at the introduction. We're going to look at the experimental probability. We're also going to look at the range of probability measure. We're going to look at the probability space, and lastly, we are going to look at theoretical probability. And let's start with the introduction to probability. Number one, we need to ask ourselves, what is probability? And the probability is the numerical measure of a chance. Let's look at a few examples here so that we can be able to get an idea what the probability is all about. So, example 1, at a start of a football match, we usually have a coin is tossed to decide which team is to start, because either team can start, either team A or team B. But now, when you're starting the game, which team will go to start, this one is decided by tossing a coin, where either team 1 or team 2 is going to start, depending on the coin choice of the toss. Another case we can look is whether when we have a farmer, number 2 here, would like to know the likelihood of his cow giving birth to a heifer if the last 6 births it has given 5 bulls and 1 heifer. So we have a farmer here, and his cow has given birth to 5 bulls and 1 heifer. So now, if this farmer want to get to maybe just to know what is going to be the 7th born, in this case, the farmer will require the probability and knowledge so that he can be able to determine the chance of having either a bull or a heifer in the 7th birth. So let's move on to the next session, that is about experimental probability. So when we talk about the experimental probability, this one involves determining of a chance using result from tests previously conducted. So each test is called a trial. So the possible result of a trial is called an outcome. So experimental probability of a result is given by the number of favorable outcome you divide by the total number of trials. So let's give an example. Like the case of the farmer having a cow giving birth to 5 bulls and 1 heifer in the last 6 births. So you may be required to maybe ask yourself, what's the probability of getting a heifer in the 7th birth? Number 1 is to ask ourselves how do you get the probability? So we have said that the probability is given by the number of favorable outcomes we divide by the number of total trials. So in our case here, we have we want to the probability of getting a heifer. Let's just say a bit of h. So this one is going to be given by the total number of favorable outcome. How many heifer have we been having in our previous birth? So we only have one heifer. So this is our favorable outcome. So we are going to be having S1. Then we divide by the total number of the trials. So the total number of trials in our case, we have 6 births. So So that is the total number of the trials. So we divide by 6. So our probability of having the 7 birds having a heifer is going to be given by 1 out of 6. So our next point is look at the range of the probability measure, and can go through what is the range of the probability measure. So the greater the probability, the more the event is likely to take place. The probability of an event A, which is certain to occur, is 1. That is, probability of A is equals to 1. So if we have something that we know that is going to occur, we have the so in that case we say that the probability of that event occurring is 1. And the opposite, the probability of an event A which is impossible to occur is 0. That is, probability of A is equal to 0 for that event that is impossible to occur. So the probability of an event A lies between 0 and 1, and the 0 and 1 are included. That is, the probability of an event A occurring is either greater than or equals to 0 or less than or equals to 1. So this is the range of the probability measure. So if PA is the probability of an event A happening, then PA prime is the probability of an event A not happening. That is, we can say that probability of A prime is equals to 1 minus probability of A. So, or in other case, you can say that the probability of an event not happening plus the probability of event happening, then when you add them, they give you 1. So probabilities are expressed as fractions, decimals, or percentages. So the next thing that we need to get to understanding is the probability space. We can look at it as now the list of the possible outcomes in a given scenario. So the list of possible outcomes is called probability space or sample space or the probability. So those outcomes that we expect from a given event, that is what we talk about the probability space. An example, when a fair coin is tossed once, the possible outcome is a head or a tail. So we can maybe talk about H for head, T for a tail. The nature of a coin is such that the head or a tail have equal chance of occurring. So the event a head or tail are said to be equally likely or equiprobable. So in that case, you can have either a head or a tail. So those are the outcomes if we toss a coin. So let's look at the theoretical probability, another thing that we need to understand. So it is the theory behind probability. We talk about the theoretical probability. This is the theory behind probability. So it gives the outcome of the occurrence of an event based on mathematics or reasons. So it tells us what should happen in an ideal situation without conducting any experiment. So useful in a situation where it is not possible to conduct an actual experiment to arrive at a sound conclusion. Example, when launching a satellite. So when we have a theoretical probability, this is the way you can be able to tell the outcome based on mathematics or even some reasoning of a particular outcome without doing that actual event. So that is the theoretical probability. I'm going to do some examples here. So example 1, we are going to have when tossing a two-fair coin, what are the possible outcomes? So in this case, we have 2 coins, and you know, of course, a coin have a head and a tail. So for us to get the possible outcome in this case, we can draw a table. So we have maybe the one coin here has the head, the tail, and the one we have a head and a tail. So this is maybe we can talk about the first coin, and in this case you can have the second coin. So when you have it like that, so in this case the first outcome here, you can have the head from the first coin and the head from the second coin. That's another output. The second one is the tail from the first coin, and then the head from the second coin. Then another outcome here, it is the head from the first coin, and then tail from the second coin, and the other outcome here will be the tail from the first coin, and then the tail from the second coin. So those are our possible outcome when we come to if you toss a two coin. So these are our possible outcome. So a head, tail, tail, head, and then tail. So we have 4 outcomes. So when we toss two fair coin once, so in this case, in one, if a person is interested to asking maybe the probability of getting maybe 2 heads, let's say probability of getting 2 head, that is head and head, that one will be we have one case here, head and head, so it is 1 out of the 4 outcomes. So it is a quarter because we have a head and head only once. So maybe if you maybe interested to getting the maybe say the probability of getting a head and then a tail, or let's say a tail and head. So in this case we have 2 scenarios. There are 2 of them. We have a tail head and head tail. So these 2, so that one is 2 out of 4 outcome, and that one is the same as, if you simplify, same as half. So probability of getting maybe a tail and a tail will be, we only have 1 instead of a tail and a tail, so this is going to be 1 and then out of 4 outcome. So that is how you can be able to answer and maybe to get to understand the possible outcome for the 2 coins. Let's go to example 2. 2 dice are tossed together. Find the probability that the sum of the 2 upper faces will be 7. So number 1 thing that we need to know is that a die has 6 faces, and they are labeled as 1, 2, 6. So labeled 1, 2, 6. Then number 1, and another thing that we need to understand is that for a die, opposite faces add up to 7. So opposite face add up to 7. So let's say that if one face is 2, then the opposite of it should be 5, so that the opposite should add up to 7. So to answer our question, we need to have the probability space or the outcome that we can have when we have the two dice being tossed. So I'm going to do a table to be able to answer that. So on one side you can have the first die, and then on this other side you can have the second die. So in this case we are interested with the sum of the upper faces. So we are just going to have the sum in our space. So in the first case we have 1 plus 1, so we are going to have 2, then 2 plus 1 plus 2, 3, 1 plus 3, 4, 1 plus 4, 5, 1 plus 5, 6, then 7 there. So you're just adding, so 2 plus 1, 3, then you're going to have 2 plus 2, 4, then 2 plus 3, 5, 2 plus 4, 6, 2 plus 5, 7, then 2 plus 6, 8. Then the third one, we are going to have 3 plus 1, 4, 5, 6, 7, 8, 9. Then 4 plus 1, 5, then 6, 7, 8, 9, 10. Then 5 plus 1, 6, 7, 8, 9, 10, 11. Then we have 6 plus 1, that is 7, 8, 9, 10, 11, 12. So that's our possible outcome, and we are interested, the first part, the question A, we want to get the probability of getting a 7. So how many 7 do we have? So from our case here we have this 7, that is 1, 2, 3, 4, 5, 6. So that is why you have 7. So we have probability to be equals to 6 out of the outcome, or the outcome that you have should it be 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. So all of this one, 6 by 6, meaning it will be 36. So that is the probability of getting a 7. Then part B is the probability of getting a sum of 9. So you're just going to calculate how many 9 do we have as our outcome. So we have 1, 2, 3, 4. So this is 4 out of 36. We can simply simplify this one. In any case, the final answer can be simplified. This is going to be same as 1 over 9. And for the first case there, by 6, 1 you get 1 over 6. So that's how you can be able to perform that probability of the two dice being tossed together. Let's look at the last question. So in this case we have a basket that contains 5 red balls, 4 green balls, and 3 blue balls. So if a ball is picked at random from the basket, find the probability that the picking a blue ball, and then part B, probability of not picking a red ball. So we start with the first part, part A. We are informed that the basket has 5 red balls. So we come to the solution here. 5, so we have 5 red, we have 4 blue, 4 green, and then you have 3 blue. So we want to pick, we want to get the probability of picking a blue. So probability of picking a blue, we ask us how many blue do you have? In our case, we have 3 out of now the total number of balls that we have. So we have 4 plus 5 plus 3, that is 5 plus 4 plus 3, and that one is going to give us is 3 out of 12, and you can simplify the final answer to be a quarter. So that is the probability of picking a blue ball. Then lastly, we need to get to answer part B, the probability of not picking a red ball. So when we talk about now the probability of not picking a red ball, we need to we can either pick a blue and maybe a green. So in our case here, the red ball are 5. So probability of now not picking a red ball is going to be given by the probability, so part B here, probability of not picking red, let me just call it red prime there, will be probability of picking now the green and blue. So green and blue, they are 4 plus 3, 7, and then we divide by the total number of balls, which are 12. So that is the probability of not picking a red, or in other words, if you are picking a green or a blue. So that's how we can be able to have the probability space and be able to solve that question in that order. Thank you for your time.